Welcome to another tutorial video. In today's tutorial, we will see how we can connect a sensor with the PLC. Before starting, I would like you guys to please subscribe this channel and press the bell icon to get notification of the upcoming video tutorials. Before we see how to connect a sensor to a PLC, let's discuss the wiring of the sensor. As you can see that, this proximity sensor have 3 wires. Blue and brown wires are to connect 24 volts power to the sensor. If we connect the 24 volt positive at brown wire, and 0 volts at blue wire, it will power on the sensor, and it is now ready to sense the objects coming within its range. Next, we have a black wire. This black wire will give us the output signal of the sensor. This output signal can be a 24 volts DC positive signal, or 0 volts DC signal depending upon which type of the sensor we are using. PNP sensors produce a positive output signal, while NPN sensors produce a negative signal during an on state. Let's see how and where we have to connect these wires in the PLC. First, we need 24 volt DC power supply. Some PLCs have onboard 24 volt DC power supply. We can use this power supply to power on some input devices or sensors. If a PLC don't have onboard DC power supply, we can use an external 24 power supply to power on the sensors. We will connect brown wire at 24 volt terminal, and blue wire at 0 volt terminal. This will turn on the sensor. Before we connect the output black wire to the PLC input terminal, we have to connect a wire at sync source or SS terminal. The SS terminal is used to configure the unit inputs for syncing or sourcing signals. The inputs terminals of the PLC themselves are polarity insensitive, and SS terminal is their common. When the SS is connected to the logic ground or 0 volts, the inputs will turn on with sourcing signals or positive signal coming out from the PNP sensors. When SS terminal is connected to the 24 volt positive, the inputs will turn on with syncing signals, or negative 0 volt signal coming out from the NPN sensors. Now let's connect the sensor wires with the PLC terminals. First, we will connect brown and blue wires at 24 volt DC terminals to power on the sensor. Next, we will connect black wire at X0 PLC input terminal. As we are using a PNP sensor with positive 24 volt DC output signal, we will connect 0 volt DC with the sync source terminal. Now the wiring is completed and sensor is connected to the PLC. As we bring a metal part close to this PNP sensor, this sensor senses it and outputs a positive signal which goes to the X0 PLC input terminal. Let's see more about the PLC input signals, where these input signals goes, and how does a PLC maintains the updated status of these input signals. Each input terminal of the PLC is connected to an individual optocoupler IC. Optocouplers are often used to reject back EMF, noise, and electrical surges from entering PLC circuit. Optocouplers create a safe connection between high-voltage equipment and microcontrollers with a means of complete electrical insulation. Now each optocoupler signal is linked to the input scan table. This input scan table contains the real-time status of each input terminal of PLC. If all inputs of the PLC are low and there is no signal at the PLC inputs, then this input scan table contains zeros against each input. And this table is updated in each PLC scan cycle. Suppose if the X0 input goes high, it will update 1 in the input scan table against the X0 PLC input. If again X0 input goes low, it will update 0 in the input scan table against the X0 PLC input. So, from this input scan table, PLC knows the status of the inputs all the time, and perform real-time logic operations. That's the end of today's tutorial. If you like, please share, like and subscribe this channel and press the bell icon for more upcoming video tutorials. Till next time, take care and goodbye.